Okay, so we've got just this little bit left. It says, on what intervals is f of x increasing? So you might first look back up at our chart. We had some values of f of x and see where it's increasing. Seems like, okay, it goes from 5 to 0, that's decreasing. 0 to -6, decreasing. -6 to -4.5, that increase. -4.5 to 12, that increase too. But you can't just use this chart because it doesn't really show what's going on between those points. So just like always when you have a table of values, make sure you're getting the full information in the problem. And so when this problem says, where is f of x increasing, you want to think about the derivative. So whenever a question asks about when is a function increasing, you always want to think, when is the derivative positive? Okay. And so we need to think about what f prime of x is. If we look back up at what f of x is the integral from 3 to x of f of t dt. So if we want to find f prime of x, we use the second fundamental theorem of calculus. We take the x, plug it in for t, so it's just f of x, multiply by the derivative of x, which is just 1. So this graph here is actually the graph of f prime of x. So again, this is our derivative graph. So if we want to see where f of x is increasing, we look for where f prime of x is positive, which is where little f is positive. So it's the same highlighted space that we had before. So our answer is actually going to be the same as number 2. So we can say f of x is increasing on the interval from 5 to 10, 10 included, since f prime of x, which is equal to f of x, is greater than 0. Or positive, either one is okay. Same kind of answer for number 5. F of x is decreasing on the interval from 0 to 5, since f prime of x, which equals f of x, is less than 0. Okay, 6 and 7 ask about concavity. So this first one says, on what intervals is f of x concave up? So for concavity, you always want to think about the second derivative. So for concave up, we want the second derivative to be positive. So what that means is the second derivative is f prime of x has to be positive. Okay, so just like from this problem, f prime of x is equal to f of x. So big F double prime of x is equal to just f prime of x. So we just took the derivative again. And if f prime of x is greater than 0, that means f of x is increasing. So if we look back up on our graph, we can see where f of x is increasing. That's from here at 3 all the way up to 7. So it's that piece right there. So the slope is positive. So our justification, f of x is concave up on the interval from 3 to 7, since f double prime of x, which equals f prime of x, is greater than 0, or f of x is increasing. Now on the AP test, you wouldn't have to list all of those justifications. Any one of them would work. Since big F double prime is positive, little f prime is positive, or f of x is increasing. Any of those would work. Okay, for f to be concave down, it's kind of the opposite of this. We want our second derivative to be negative. So little f prime negative, which means that f of x is decreasing. If you look back on the graph, that's going to be from 0 to 3. So notice this part up here is constant, so we're not going to include that in our answer, just 0 to 3. So our justification, since f double prime of x, which equals f prime of x, is less than 0, or little f of x is decreasing. Okay, so this time, if your notes are finished, I need you to go ahead and get the exit quiz from the sub and take that, and then work on your IP. So please email me if you have questions. We'll talk about all of this stuff in class tomorrow.